Hello, everybody, and welcome to today's webinar. Thank you for taking a portion of your day to join us today. My name is John Mullins, and we'll get started here in just one moment. So go ahead and get comfortable. We'll get started. All right, let's jump right in. I know you've got a lot going on, so here we go. So thank you for coming again today. My name is John Mullins. I'm from Themis, and today's webinar is a little bit different. Typically in the past, we've had a focus on a particular topic or a group of related topics, and today we're going to kind of mix it up a little bit. So you may have received an email a while back announcing this particular webinar with a request to send in any questions you might have. And so I got some good questions from various groups across the world. And with our time frame that we have, kind of picked out a few that I knew were important to a large group of people. I tried to pick out questions from different areas, whether it be from development or support or whatever type of staffs. So picked out a few there. Some of these topics warrant much more discussion. So some of these topics are almost a class on their own. And so we'll go through it as much as we can today. You'll notice on the screen there my email address. So if you have some questions regarding either the topics from today, or if these topics raise further questions for you, feel free to send those to me. Usually with the time frame that we have and the material we have, it's difficult to get to additional questions during the presentation itself. But I will get back to you later. I know I've corresponded with a number of you prior to the class regarding some of the questions that you may have had, and I also got a few requests for if I had any further information to be able to send that to you. So I certainly will do that as well. So through here, if you want to, like I said, jot down my email address. That's the best way to get the questions in there. I know you'll have some questions as we go through the topics today, but send me through that email. That's the best way and the most timely way for me to get that. That way, we aren't going to spend too much time on any particular topic and miss out on some of the other topics that we have planned for today. You'll also see our company website address there too, themisinc.com. Go there. There's lots of stuff out there. There's course outlines, there's schedules, there's our past webinars are out there as well. So if you go to that website, up on the top, there's a link to webinars. You can get a hold of slides and recorded presentations from past webinars, and there's quite a few out there as well. So feel free to do that. And today's slides are already out there right now, and the recording will be out there either later today or tomorrow. You can also follow us out there on Twitter as well. All right, so let's get going here. I recognize a lot of your names there from past webinars or from classes that you've been in. And so I don't know, a lot of you know me as well. Again, my name is John Mullins. Most of you know that I also live down in Dripping Springs, Texas, where it's going to be in the 70s today, so that's lovely, even though it's only February. I work for Themis Inc., and Themis Inc. teaches, we'll talk about them in here in just a minute, but they teach a lot of different classes from Oracle to DB2, Java, those types of classes. My background is I'm coming up on about 34 years almost of Oracle experience and SQL experience and just experience in general with other database vendors also. So started a long time ago back in the 80s using Oracle as a developer, programmer, DBA, and I am an Oracle certified professional as well and a certified technical trainer. Having had a lot of you in classes, I've taught a lot of classes over the year, from very beginner to advanced type classes to new features to DBA to whatever type of classes. So good to have you here for today's webinar. Here's just a little bit about Themis, and we go through this with all our webinars, so hang with me here just for a second. But Themis has been around for a long time as well, teaching lots of classes, lots of students, and you can see the types of courses that we teach there: DB2, SQL Server, Oracle, Java, Linux, whatever, down there. And there's our web address again, and again you can go to our web address, click on webinars, and you can get information on that. All right, so let's go to the topic at hand here. We're here for a webinar, and this webinar, like I said, is a little bit different. I've gathered some pre-submitted questions. At first when I thought about this webinar and wanted to do something a little bit different, I kind of thought, why don't I just open it up and we'll just have a free-for-all, and people can ask their questions right there at the webinar. But then I realized too that makes it a little bit difficult to kind of plan within the time frame we have, and it may not be a good representation of different topics that would be of interest to the wide range of people that typically attend these webinars. So we ask for questions up front. Sorry if your question doesn't get presented in the webinar itself, but if I have any of those other questions that I don't address today that aren't part of the webinar, I will answer for you and get back to you with those as well. So if this generates some questions for you later on, be sure to send those to my email address, jmullins@themisinc.com. All right, let's jump right in and see. You might see it. You won't see up front whether or not your question that you submitted is coming up just yet. So hang in there. What I'm going to do is address 5 questions. I kind of figure that's what we have kind of time for today based on the types of questions there are. Some of the questions we'll go through quicker than others because some of the questions are bigger. And like I said, some of these questions, it could be a 2 or 3 day class if we wanted to address them in great detail and have maybe some exercises and things like that. But we'll do our best to get you off with some information today. Hopefully that'll trigger something for you if you're having some difficulties at work with a particular topic, or if you're going down a certain lane, it may direct you the right way at that fork in the road, those types of things. And of course, follow up with some questions later down the road also if you have any. So just send those to my email address again. All right, let's see here. These questions are kind of in a random order, so I didn't pick out the longer ones first or the shorter ones first or anything like that. So let's see what we got for some of our questions. Some of the questions you might look at and say, yeah, that doesn't really apply to me, type of thing. But that's the way the webinars go there. And so hang in there, because I said I did pick a good variety of questions, I think, anyway, for people to kind of look at today. All right, let's jump into question number 1. All right, it's an SQL type question. And these are questions that, like I said, I kind of pulled from a bigger group of questions that we have, and we'll certainly get back to the other ones outside of the webinar. But here's the question. Can the with clause, which is also referred to as a subquery factoring clause or just subquery factoring, what about performance benefits with it? A lot of us understand the readability benefits of it, but we may not understand fully, can I get performance benefits from it? And if I can, what types of queries, what types of subqueries will allow me to realize those benefits in performance? Because maybe you've tried it and you didn't see the benefits for performance. It ran about the same, or maybe it even ran slower. This is something we talk about in our SQL tuning classes. We also talk about it in the advanced SQL type classes. So under certain circumstances, absolutely, we could see some performance benefits, but it's going to depend on a few things. All right, so imagine your select statement, select blah, blah, blah from whatever, where, whatever, those types of things. Maybe you've got, in this case, you will have one or more subqueries down there in your select statement. And so we want to know if I pull those subqueries out and I list them in the with clause, and I'll show you an example of some code here in just a second, can I realize the benefit of as far as performance goes? And the first sub-bullet up there is important, where it says when repeated references to the subquery are made. Okay? So think about that. You know, if I just have a regular select and it only has one subquery in it, I'm probably not going to see any benefit to performance there. What Oracle's going to do behind the scenes with these with clauses, it's either going to, it does one of two things, and you can see that with the second sub-bullet there. It's either going to process it as an inline view, which may not help me a whole lot, or it's going to resolve it as a temporary table. Not one that I have to create, though, so that's the good news about that. You'll see there's a couple of hints available at the bottom. I'm not a big hint person, but if all else fails, I will go pull a hint out of my pocket once in a while. You can see here the materialize hint. If I'm not getting that performance gain that I would like to, I could use that. And the materialize hint is trying to coax the optimizer into choosing that temporary table route there, whereas obviously the inline does the inline view type thing there. So what we want to do is take that subquery, hopefully that's repeated more than once, because that's where we're going to get our gain, and materialize it so that it's basically, instead of running it every time it's referenced in the main query, it's basically executed once, and the results of that are stored in a temporary table that will then reference by name down in our main query there. So really the only time that we're going to see maybe a big benefit from this is, again, is if we have repeated references to the subquery. And I've talked to a number of people that they come to class and they want to know if the with clause is a new thing because they haven't seen it before, and it's not. It's been around for quite a while. They go back to work, and pretty much everybody goes back to work and tries it under these kind of the scenario that you see here with the repeated references. I haven't had anybody come back to me and saying, yeah, it didn't do much for me. Most of the people are reporting a pretty big percentage as far as performance gain. Of course, that depends on the subquery and your main query and your volume of data and lots of other things too, right? Memory structures, indexes that are in place, and things like that. But so take advantage of the with clause of the subquery factoring clause, and to answer the question, yes, it could provide for us a performance gain there under the scenario of repeated references to that subquery. Here's kind of let's see here. Here's just an example real quick of some code. I won't go through it line by line here, but you can see up here at the top I have a subquery factoring clause, and I have it named as department count. He's just getting the number of employees by department there. Okay. And you can see down here in my from clause, I'm referencing that department count more than one time down there. So I've got, depending on what I'm trying to get out of my main query, but I have a need in this case to reference it twice. You can see down there in my from clause, I'm doing from the employee table, then department count, then the employee table again. So I've got employees, I've got managers, and then I reference department count again at that point in time. So anytime I have those references, just any place I can have a from clause down there in the main where I can reference that department count in the top, since it's referenced more than once, it could be 2 times, 3 times, 4 times, whatever, I'm going to get a performance gain. And depending on lots of things, it could be either very small or it could be very large. Okay, and again, remember, all these slides are available out at themisinc.com. If you click on webinars, these slides are already out there right now. All right, so that was our first topic there. I said I pulled 5 questions for everybody today. All right, I had a question about Exadata, and had to do with storage indexes And the question kind of went on into database indexes as well. And so we know that Exadata is one of those hardware, software solutions that we could get into, that we look for large performance gains, hopefully, and hopefully more out of the box than a lot of effort on our part. But it's going to take a little bit of work on our part for sure. We don't just plug it in and necessarily see it improve everywhere. It might improve for some types of queries, but not others. It might be slower for some types of queries than others as well. So we're going to talk about this. We're going to focus a lot on those storage indexes here because a lot of you are already familiar with the regular database index, so otherwise known as a B tree index. And those are the ones that we're used to outside of Exadata. So those are helpful. We'll say we submit a query, select whatever. The optimizer goes out there and says, how should I run this query? This is pre-Exadata at this point. Let me see. Let me check on some statistics. Let me check on some other things. Let me check on indexes. Oh, here come those indexes into play. And I'm going to try to figure out which of these different scenarios, do I have a join involved here? Which of these scenarios is going to basically use the fewest amount of resources for this? And then based on that, I'll use that as my execution plan. So I could do a full table scan on one or more tables. I could do index scans on one or more tables. I'm just trying to figure out what's the less amount of I/O here to get the result back. And then I'll store that in memory. And next time these queries are executed, we can use the same execution plan that's there or whatever. Now, part of the problem with the pre-Exadata is that the data that we're talking about, either the full table scans or the index scans, those are arranged in blocks. And by default, those are 8K blocks. And so if I do a select, depending on what my cardinality or result set's going to be, I'm going to get so many blocks up into memory on the server. Those blocks are, like I said, they're 8K, and they're going to contain not only the data that I want, but they're also potentially could contain data that I don't want. Maybe I only want to select 3 columns, not every column from the tables that are involved there. What if I only want certain records in the result set based on certain criteria? Well, the problem is I'm going to restrict it by the number of rows. I'm going to restrict it by the columns I see. However, in the pre-Exadata scenario, I'm still going to get all that in a block. And so I'm going to get all the other, because in that block are rows or records. And so I'm going to get other columns loaded into memory when I only wanted 3 of them. I'm going to get other rows loaded into memory even though I only want these based on this criteria. So I'm not making very efficient use of my memory. I'm not making very good use of my I/O capabilities because I only want these 3 columns for these rows for this criteria, but Oracle's giving me back more data than I want. Just like kind of like a Cartesian join where you get more data you want. Same thing here. And that data is going across networks. It's consuming more memory than it needs to. Those types of things. And so it's not real efficient that way. So then here comes Exadata. Okay, Exadata being a kind of a hardware software solution. I've got these hard drives that are set up a certain way. Down in that Exadata environment, I have something called storage indexes, which we'll talk about. I have something called a smart scan, which we'll talk about as well. And there's memory down there too. Okay, and so here's just a kind of a 1-2 line benefit of the Exadata. Remember what the big problem was outside of Exadata. Even though I only asked for a certain number of columns and a certain rows, because of the block being the smallest item in the architecture, I get more columns and more rows. And so if I could eliminate that and only get what I asked for, I only want these 3 columns and I only want these rows. If I only get what I asked for and not all this excess stuff, that should be faster because it's not sending as much stuff across the pike there. Plus, the Exadata is also going to take advantage of something called in Oracle the direct path feature, which means I bypass a lot of the memory structure in Oracle, which is called the database buffer cache or buffer cache up there. And the results will be sent as just bytes, not blocks from the Exadata environment, bypass the buffer cache and be sent directly to each connection that has its own PGA or own kind of like private memory area associated with it. So I'm bypassing certain things, like I'm taking a shortcut, and I'm only sending you what you asked for. It's similar to this. What if you asked for, oh, I know there's a good article in that magazine, right? Can you let me borrow it? Well, I can let you borrow the whole magazine, but you're only interested in, say, 5 pages in there. That's the same thing that's going on here. If I could just give you the 5 pages out of the magazine, maybe stapled together or in a file or something like that, it's not going to be as big a thing in that case there. So we only want to receive what we ask for, and that's what Exadata is about. So let's take a look at the index part, because that's what the question's all about here. Here's kind of just a high-level view, and this is like I said, I have 5 questions here, but some of these questions are a little bit more detailed than others. So these storage indexes versus database index. Okay, so the database index, we know it's made up of those blocks. It's a physical thing. Those blocks are loaded into memory, but it's also a physical thing on disk. So if they're not in memory, I have to read it from disk, put them in memory, and then it can be used there. So that's how those blocks are arranged. It's kind of arranged in a B tree, 2 or 3 or more levels of that tree. So I may have to do multiple I/O through the tree just to get to the blocks where I kind of can find out where my data is in the blocks for the table, and then I'll get those blocks, but again, those are containing more information that I want. Whereas the storage indexes, look at the third sub-bullet there, I think that's the most important one, they just reside in memory. Down at the Exadata, what's called the storage cell or storage server down in that area. It's required that they work with the Smart Scan. Smart Scan is kind of the filter area that kind of makes all the decisions down there. So they work with the storage indexes down there. And you'll see here, I'm going to focus on those storage indexes here in just a second, so I'll leave some of the stuff for the slides that are coming up. But think of it this way, those storage indexes, you're going to see on some pages that are coming up, they're created automatically. A database index, you have to consciously, explicitly create the index, either unique or not unique, and all the other stuff that goes with it. Storage indexes get created automatically based on any repeated queries that are sent to the storage cell. So the optimizer up in the database layer kind of decides, where am I going to go? Am I going to process this in the database layer, or am I going to process this in the Exadata layer? And so if he's sending queries down to, and we'll talk about these queries in just a bit, sending these queries down to the Exadata layer, down there, the Smart Scan feature is going to be there. If this is a query that's been down there before, it may create some storage indexes, and we'll see more about them in a second. But a storage index goes out based on the values kind of in your where clause. So a predicate or a where clause is going to be required for this. And based on what you're searching on, he's going to go through the data that resides down there in the Exadata level, and he's going to break it apart into pieces. And he's going to come up with a high value and a low value based on whatever data you're going after and where that's located down there. It's very much like a partition table, if we want to compare it to something. It's not processed the same way, but the concept is the same way. If you remember if you know what a partition table looks like, we're going to break the data in the table into different pieces there as well. It could be based on a list of values, a range of values. Down here, it's going to be broken apart into a high value and a low value, so that when you come in there, the Exadata feature can scan these ranges, and if you're looking for something equal to this, he knows which range of high and low values, where that data resides, and then he can eliminate the other data as far as having to read through it and having to return it back up to you too, to have it throw out data at the database level. It's almost like it's the opposite of a database index, right? Because it acts, kind of like to think of it as it acts as a negative index in this place, because what he's going to do is throw data out. Okay, and you'll see that coming up here in just a second. So this is just kind of a high level here. So let's jump into those storage indexes a little bit. And here's some of the stuff I was just talking about. Going to divide the physical table data into storage regions. They all get a high value and a low value. Okay. That third bullet was the one I was just talking about. Identify areas that do not contain the values and takes them out of the I/O processing. And again, he's doing what's called column projection. So if you only want these 3 columns, that's what you're going to get. Okay, and you can see there the last one, like I said, they're created automatically down there as well. Okay. Yeah, I like that third bullet there. Identify areas that do not contain the values. You know, if you've taken any of our classes and we talk about indexes, we often refer to kind of compare an index in the database to an index in the back of the book. And we also talk about things that could negate the use of an index, like a not equal operator. And so when we see that, we compare it to the reference index in the back of a book, saying, does the index in the back of the book, does it tell you what's not in the book? And we say, no, of course not. And same thing with the regular database index that's out there. But notice what the storage index is doing. It's the opposite of that. It's identifying the areas that it doesn't want, not the areas that it wants. It's identifying the areas that it doesn't want. And that's a little bit different thinking for us. All right, let's move on here and talk a little bit about the queries that could go down there then. All right, as some of you already know, not every query, I'll say application here, but not every SQL query is going to benefit from these storage indexes. Okay, and I've kind of highlighted here, only certain types are going to see the benefits of this. And then look at the second sub-bullet down there at the bottom where it says applications that include predicates, that's the where clause, and perform full table scans or fast full index scans. Okay. Now what we have to decide is, you know, if I've got, say for example, you submit a query, a select from wherever. The optimizer takes a look at it. You're not necessarily in a data warehouse type of environment. You're in an online transaction environment or some sort of hybrid between the two there. And the optimizer decides, oh, I'm going to look at the index, see what indexes are out there, check statistics. Based on what I see here, oh, there's a very good B tree index that would be great for you. So I'm going to make that your execution plan. If that's the case, he's not going to go to the Exadata into the storage index area. He's going to use the database index instead. And in some of our classes, we've had some pretty big discussions about this. It's like, okay, in order to drive stuff to the Exadata environment, because it seems like should everything go there, almost type of thing. Should we drop some of our existing database indexes for certain queries? Should we make them invisible so that the optimizer doesn't know about it? And so the optimizer says, oh, I don't either see an index or it's invisible. I'm going to do a full table scan, and that means, oh my gosh, I could then maybe go down to the Exadata level. And so we have those types of things, but we also know that those indexes are in place for a reason. Those are the smaller sets of data that we're going through. Those are the smaller result sets where an index would be very beneficial in the database half of this architecture. So we'll leave it up to the optimizer to decide, should I process your query in the database layer or should I process your query in the Exadata layer? And we can tell what it chose by looking at, for example, the results of an explain plan utility. It'll tell us if it went to the Exadata or not. So if you haven't been doing that, take a look at the Exadata there. Remember that these storage indexes are in memory only. They'll exist and live, basically forever until that storage infrastructure, the Exadata architecture down there is shut down or goes down for some reason. So it's kind of like the memory up in the database layer. If Oracle, the instance goes down, then you lose everything up in memory up there. Same thing down at the Exadata level. Otherwise, these storage indexes, they're created automatically, and they persist and they stay around for as long as you need them. All right. Last bullet there, the storage index will send bytes, not blocks, back to the database server there. All right, let's talk about these a little bit more. Now, the term we're looking for here is the work is being offloaded to the Exadata layer. Okay, and so that's what it walks here, talks about that, but it has to use the direct path mechanism. Now, there's only certain types of queries that will, by default, that'll use that direct path mechanism. Sometimes if you put a query into a certain parallelism, that'll do that. Even sequential or serial processing, so like a select statement with an order by on it, he'll break the order by into some degree of parallelism, even by default, whether we know that or not there. So remember, with the direct path, that's part of the prerequisite as well. If he can process your select with the direct path read, which means that the data is returned back to the individual process's PGA, which is that private or process global area there, just the bytes, not the blocks. Okay, and you can see there that direct path reads are only available for full scans, both table and indexes. So if he comes up with a different execution plan, you're not going to get down to the Exadata level, or layer, I should say. And that's what that last bullet there at the bottom says. If he says, I'm going to do an index range scan, which is very common, right? Especially before we went to Exadata, we may have gotten a lot of index range scans as part of our execution plans. It's not going to go to the Exadata level. So let's move on here. A few other statistics here about this. And one thing is going to come up really important on this particular slide here. So, what SQL statements actually are eligible for Exadata or storage index processing? Well, we know that the full table scans, full index scans, fast full index scan, for example, it has to have a predicate or a where clause. So it's not enough for it just to be doing a full table scan. In other words, if you don't have a where clause, some sort of a predicate, that's going to make it ineligible for the Exadata layer down below. Okay. Now, there's a couple of views, which are actually data. These are dynamic performance views, but they're really synonyms, but we'll call them views, but I put both on the screen there. There's one called $SQL FN _ metadata, and then, of course, there's the one, you may not be familiar with that one, but there's also one called $SQL, which you might be familiar with. That one's been around for a long time. The $SQL FN metadata, it has a column in it called offloadable. And both of these will kind of give you some of the same information, but they also give you a lot more information that the other one doesn't give you as well. You can see on the $SQL, there's a different column called IO cell offload eligible bytes. All right. Both of these, what these columns will tell you is, the first one's the offloadable is either a yes or a no. Okay, the second one shows us, and it's pretty handy here, how many bytes were processed if they were offloaded and used a storage index. So if I'm wondering, okay, my query's not running as fast as I think it should be at this point, I can look, all queries are still, all SQL statements, PL SQL statements are still all loaded into the $SQL area that we can access, which is the shared pool area in memory. For any query statements that I've already run, I can do a select against $SQL, looking for, there's an SQL text type of column in that particular view. So I can do a where clause, like something in my query. And one of the things I may want to select is the IO, or I will want to select, if this is what I'm checking for, this IO cell offload eligible bytes. If that's 0, then I know my query that I've already run did not use the storage index. So what I'm looking for, and there's a lots. If you go out there and Google especially the first view up there, that SQL FN view, there are a lot of queries available out there on the internet that'll give you, they're already written. You can take those, modify them as you need to. But that way you can see, okay, was this offloadable or not? If it wasn't, and I was expecting it to be, why wasn't it? Like I said, there's certain rules to be offloaded and to use storage indexes, predicates, where clauses, full table scans, full index scans, fast full index scans, I should say. They often talk about queries that have aggregate functions in them. Those are qualified to be offloaded and use the storage index as well. So some of the tools we can use to kind of get to question 3 here, and this is a lot of information. This is the topic I was talking about that could be 2 or 3 days worth of discussion. Hopefully there's enough in here to kind of get your eyebrows raised a bit and say, I'm going to check that view when I get back to work and see what it says for the queries that I've been running. Or do a Google on these views here, and you'll find some other helpful queries out there for you as well. And I've Googled it out there, and there's plenty of them out there. And remember, the explain plan utility also tells you where am I going to process this statement, in the database layer or in the Exadata layer. So kind of summarize that. Storage indexes are memory only, created automatically. They create I'm going to use the word partitions, but they create groups or ranges of data dependent on what's in your where clause. That's why it needs the where clause. So he can create these different groups of data with a high and a low value. So he can go through there very quickly and decide, I don't need these, I don't need this group, I don't need this group. That's why you have to have the where clause. So he can create the storage index in the first place. All right, no maintenance required on them. They get created automatically. They'll stay there unless your system goes down, just like any other memory structure. You can check to see which of your queries are actually being processed down in the Exadata level by looking at either explain plan or these 2 views here. These are 2 views here after the fact. A query ran, it was slow. I'm going to check this. Did it get offloaded or not? Okay, and there's other columns in these views as well, especially the first one, the SQL FN view there. That will show you how many bytes. The other one shows you bytes at the bottom there too, but it'll tell you how many bytes were involved in this, and then it'll tell you how many bytes it actually sends back to the PGA. Okay. Remember, things that may cause it not to go down there is if he decides to do an index range scan instead, or your query is not eligible to do, say, a direct path type thing. Now, there is a direct path hint available, depending on what you're trying to do, whether it's select or insert or whatever. You see people use it all the time with the insert statement. It's called append, A-P-P-E-N-D, but hints are just what they sound like. Maybe the optimizer will take it, maybe not. There's a good chance it will. All right, there's a lot of stuff there on that one, but hopefully that helps you a little bit understand what's the difference, at least between a storage index and a database index, and also what types of queries are going to go down to the Exadata level, so you can take advantage of this great Exadata architecture that you purchased and get your money back on it, performance-wise, right? All right, let's look on to question 3 here. Like I said, I've got 5 of these, and then if you have questions later, you can send me an email, and I already promised to send some additional supporting documentation to some of you as well. What about, this is a whole different type of question here. So Exadata is not in this question, but here's the question. What are the best practices related to accessing data from multiple sources using database links when it comes to performance? Okay, so for those of you that maybe aren't as familiar with database links, so I'm in a database, I'm connected to a database, I can create what's called a database link that's going to point to some other database. It could be on the same server, it could be on a different server, but I create a database link, and that way, while I'm connected here, let's say locally, I can either directly access only remote data, or I can combine and do like a join between a local table and a remote table. It all depends on what I'm trying to do with these database links here, and they could be coming from different databases, more than one different database. Each link will represent maybe a different database there. That could be, like I said, either on the same server or not. Okay, so let's see some considerations for this. All right, we've got one big problem, and this is the problem that's difficult maybe to try to solve, but when we talk about database links, you're local, you have a remote, one or more databases out there. Are we trying to push data to the remote, or are we trying to pull data from the remote? If we're running, say, a query, we usually, wherever we're connected, that's where we're going to issue the application from, that's where we're going to run the select from, or whatever it might be there, right? So typically, we get data from the local part, maybe, but we also want data from the remote parts, so we're going to pull data from somewhere. Now, it depends on how we're pulling it as to how our performance might be. Right? Notice that first sub-bullet there, that if I'm doing a join between a local table and a remote table, and maybe bringing the results back to the local environment, maybe inserting them into a temporary table or something else there, that all joins are processed on the side of the link that issues the query. Okay, think about that. That could be a big problem, right? So what it has to do first is, I've got this remote table somewhere. He has to pull the entire table from the remote to process the join locally in the let's say the PGA in your local database. Even though the result of the join might be a very small result set, right? I may have to pull 10 million records to do the join, and then once I do the join, the result is that I only result set has 5 records, right? Well, there's many different ways to do this, and this just goes into some of what we want to do is to send back or pull back as few records as possible to process our select and get our result set. So if I could, in other words, if I could do the join on the remote server and just send the 5 records back, that would be a better solution. Now, how can I get him to do that? A couple of different ways. The sub-bullet number 2 there talks about one, and that's a hint. But you see that hint come up a lot when we're talking about database links. It's called driving site, and you can see the sub-bullet under it. It dictates where the work is done. So we process it just like any other hint in our select statements. We say driving site, and then the driving site hint takes a parameter, and that parameter is a table name. And the table name that you want to put in there is the remote table that's involved there. That tells it, hey, any activity with this table here, we're going to process remotely and then just send the results back. Now, if these tables, once you join them together, is still a pretty large result set, this isn't going to give you much benefit by pushing the work out to the remote in order to process or send back or pull back a fewer number of records. I actually ran into this problem a long time ago. What we were doing was we were connected to a local database, and we were processing aggregate functions like counts and averages on different things. And the target of that count was against the table on the remote server. Well, here's the problem that went into that. I don't remember if they had joins or not in that case there, but we did a count on the table remotely. And what the Oracle decided to do in that case was, instead of doing the count on the remote server and just send me back the count, he sent me back the entire table and then did the count locally. Well, any tables that have any volume of size at all, that's not going to perform very well. Now, in that case there, through research and such and talking to Oracle, that was probably before the driving site hint came about. This is a number of years ago. They asked us then, instead of doing the count against the table on the remote, on the remote server over there, do a count over there inside a view. And then the Oracle would process it differently. So if on the local machine, if I just did a select from the view on the remote server, then the view was processed remotely and sent back the results, and the difference in the performance was huge. You may also see out there, depending on your application and what you're trying to do, I've also seen out there different studies of people that were sharing their particular results with this. And I know some people were creating stored procedures or stored programs on the remote machine and have their select in there. So the idea is to process it remotely, especially if we're going to send back or pull back a smaller result set there. Okay, you notice the last sub-bullet there too. Sometimes we access this data across this database link more than once, say in a multi-step process type thing. And so you will see some suggestions that people will say, well, it may not be the best solution, but it's certainly better instead of pulling this data multiple times across the database link, you pull it across once and then you keep it. And I know some of you have told me about your experiences trying that maybe you brought it across and put it in a materialized view. Other people might bring it across and put it in a temporary table. And then on the local machine, access that there. But then the concern is that maybe that data isn't real time, for example. Because we might pull it across. It's now loaded into some sort of materialized view or temporary table, and then we access it multiple times on the local machine, but it's never updated there until we do another pull. What that's doing is reducing the number of trips that we have to do the pull, and each pull is very expensive. That's another solution. It may not. Our goal should really be is can I reduce the amount of data coming back or being pulled back from that remote one? So we kind of have that as kind of a fallback solution to this. If I have to load it locally and then process it, realizing it's not up to date, but that makes some people uneasy or they don't like that solution. If I can find a solution that will process it there remotely and then send me back the smaller result set, so do the work on the remote server, then pass it back. Now you also have to remember this too. If I'm going to put the work over on the remote server, make sure that it can handle the extra work. Right? Sometimes these remote servers aren't set up the same as where you're logged in or your process is logged in locally. And I'm doing the work over there, but it doesn't have as much memory available. Maybe it's a busier system with the number of concurrent processes that are out there. And so we have to be careful about that. So we've got, maybe a hint that could help us here. Consider views or other type of objects on the remote system and access them remotely rather than their table remotely. Could give you something different there as well. Or you also have a third option there, which some of you may be using as well, which is reducing the number of trips, store the data temporarily in a materialized view or a temporary table there. Okay, remember the whole idea is reduce the amount of data that's pulled from the remote site. And so try some of those things there. You may try a view first and see if that does it or not. Maybe it will, maybe it won't. Or try a small store procedure. Put your select over there, or whatever you're doing over there on there, and just execute it through the database link. It'll process it in the remote and send back the hopefully much smaller result set. And like I said, if things aren't, oh, this is bigger than that and this is smaller than that, and the result set is particularly small or particularly large, those all factor into the performance of this as well. But try some of those things there also. All right, let's finish these guys off here. Let's go to question 4. This one's pretty short, and so is the last one. So I kind of saved them in case we were running out of time here. All right. All right, question had to do with bulk processing in a PL SQL program. So it talks about, I can do a for all statement with inserts, updates, deletes, and merges to process like bulk inserts or bulk updates and I'll show you some code here in a minute. And you see a lot of examples out there, maybe examples in your environment or out there on the internet or things like that. But they don't often include this returning option or this save exceptions option on there. They do the for all with an insert, update, or delete. They're getting good performance on that, but maybe sometimes they encounter errors. Maybe sometimes they have different rules about what to do with the successful part of those things. And that's where the returning and the save exceptions options come into play here. So let me show you those here. All right, this is going to be a 2-page example here. So let me go back here to the first one here. So this is just kind of setting it up on the first page here. And maybe you've seen this type of example in some of our courses. So it's creating an array type or collection type up here at the top. It's going to be an associative array. So table 1 type is a table of number. It's indexed by binary integer, and I'm assigning that new type to a number of variables here so that I have a number of collections. So that's, anytime we do this bulk processing, we have arrays or collections involved here. And then I get down in here and I'm going to do a select into a couple of those arrays here, V order IDs and V order status codes. Those are a couple of my arrays up here at the top. Okay, however many this select returns there from the what's called an order table. So it could be a few rows, it could be thousands of rows or millions of rows for that matter. Now, for this particular example, there's foreign keys involved here. I have this product order table. That's the parent table. Within that table, these status codes are foreign keys off to a lookup table that I can go to and see if these are valid status codes or not. So by doing the select, I shouldn't have any problem there. Shouldn't encounter any errors. But I want to introduce a couple, so I hard-coded a couple here. 23 and 33 are not valid status codes. So I'm going to put those into the array. All right, so that's just kind of the setup there. Now I've got reading some data, I've loaded up some arrays. Now I'm going to go into that for all statement that the question had to do with here. So if I want to save any, if I'm in this case I'm doing an update and I'm changing the order status code equal to a order status code out of the array where the order IDs match. So if any of those order status codes that come in here during the update, if they cause that update to fail, like for violating a constraint or such there, then I want to save those. And so by doing that, I can add this, you see up here at the top with the first arrow, I can add this save exceptions option up here. And I don't have to do anything else. Now, by doing the save exceptions, it's going to automatically allow me to access another array, but it's going to be one that I don't have to create or allocate. I don't have to create a new type. I don't have to associate it with a variable or anything like that. And you can see that down here in the exception section. Here's the array right here. It's called SQL% bulk underscore exceptions. So when I get done up here with this update, if this array, this bulk exceptions one, if it has nothing in it, 0, then everything in the update worked. If it has one or more values in that array, then there was some exception that was raised during the update. And he keeps track of some of that data for us. So we'll talk about that when we get down to this exception section. So that's very simple for us to set up, right? Save exceptions, and when you get to the exception section, check out the array. If it has values in it, examine those values. So he's going to keep track of for you. Down in here, you'll see within there, this is an array of records, is what it actually is. It's not just an array of values, this SQL% bulk exceptions. One of the attributes within the record is the error index, and one is the error code. The error index refers to which item in the array in the update failed. Well, we can see from here, if I go back, we know that item 12 and item 80 should be the two that fail. That's the index that we'll see down here. Okay. So we can print that out. So which item failed, and then what is the error message that went with it? And I can display those. I can send them to a table with an insert. I can write them to a file with the UTL file package, whatever I want to do there. So the save exceptions along with the array that goes with it. That's how we can get more information about any items either in an insert, update, or delete or merge for all statement that may have failed for some reason. And you can see that's very simple to set up there. Sometimes we want to know not only the ones that fail, but I could make the assumption, okay, these are the ones that fail. That means that everything else worked. But maybe I have a need to document or keep track of the ones that actually worked also. So I'm going to do this update, for example, like we see here, but I'm going to save the ones that failed, and I'm also going to save the ones that succeeded. And then I can do with them whatever I want. However, you can see here the second arrow is pointing to this returning option here. I tell it what fields I want to return. So I'm going to return the order ID and the order status code for each item that's being updated. So this is for each individual row that was updated in our statement there. But I'm going to take all those. I'm going to return them from up above for all the successful ones. And I'm going to bulk collect them into a couple of other arrays. And these two arrays here, this V order IDs 1 and status codes 1, these are ones on the previous page. I do have to declare those. Now, once the update's done, now in this set of arrays, I have 0 or more errors. In the successful one, I have 0 or more successful record items, and I can do with them whatever I want. So it gives me a lot of flexibility there, and this is a very good example on how to use that. All right, let's then go to question 5. We're about done here. This one goes pretty quick. Somebody had a question about trace event 10053, and maybe they heard the DBAs talking about it. Maybe they heard somebody else talking about it. But real quickly here, here's what it shows, and it's not for every tuning process you go through. So you've got a select statement, again, that's performing poorly. You might use this 10053. You might use this trace event when you're going back to that previous question on the storage indexes to kind of figure out, because we may want to know, we use this event for this. The optimizer comes up with an execution plan. We want to know, why did you come up with that plan? What was your thinking? It's kind of like I'm talking to my kids now. What were you thinking when you did that? And same thing here. When the optimizer comes up with an index range scan, it's like, now you cause me not to go to my storage index by doing that. So what was your consideration for that? That's what happens in this 10053 trace event. What you'll see through there, and just the next slide will be really good about this, he's going through all the possibilities. You've submitted the select or whatever, comes from an application, wherever, and the optimizer says, okay, how should I execute this? And as he's going through his thinking, okay, I'm going to do this with the tables in this order first. And I'm going to apply the predicate or this where clause condition either before the join or after the join or in between these two joins. I'm going to try that. And if you're doing a join, I'm going to check out, a nested loop join or a sort merge join or a hash join. And he's running these through his algorithm to see what kind of cost he comes up with. And he's looking for the combination that gives him the lowest cost. So you may want to do this if things like this are happening. Oh, he doesn't choose your index. Or he chooses the wrong index. Or he's doing a nested loop join on big volumes of data or result sets. And that doesn't make sense because nested loops aren't made for that. Hash join would be a better choice. So in this file, you can see it's a text file. It's already formatted. You don't have to do anything about it. You do have to run either an alter session command to kick it off, to say, okay, start tracing, or there's a package for it as well to kind of start the tracing. Run your select statement. Now, it has to do a hard parse of your select statement in order for it to show up in the trace file. Okay, that makes sense, right? Because we want to know, what was your thinking? What did you think about when you came up with this execution plan you did? If this is a statement that's been run before and the execution plan's already in memory, well, he doesn't have to think then. He just uses the execution plan that's already there as long as the statements match. So it has to be a hard parse. And we can do that a number of different ways too. If you just run it through the explain plan utility, it actually does a hard parse there. Or we clear out what's in memory, which is a little bit more drastic. But anyway, it has to do a hard parse. So you'll see things in there like, okay, and I'll show you on the next page. Here's the order of the tables that I'm trying first. I'm going to try this order with a nested loop. And then he comes up with the cost and the cardinality as far as the estimated result set and a bunch of other statistics. And if it's the very first one, he says, oh, this is the best one so far because he hasn't tried any others. Then he goes to option 2 and option 3 and option 4 until he gets to a point where he thinks this is the best option as far as cost goes. And then that's what he's going to give you in the execution plan. So what you're looking for in here is, did you even consider my index? Or why did you even consider a hash join? And what caused you to not choose it? And so it's a little bit difficult to read because the formatting is just, it's like a dump of a bunch of numbers. Let me show you here on the next page, and then we'll be wrapping up here. So here's what we'll see in here. I got one more page, actually. Here's what you'll see in there. So you'll see, the join method considered. And think about this. If you've got, I talk about this in the performance classes, like if you're doing a 5-table join, the optimizer is going to go through and look at all possible combinations of those tables. You'll see that in here. Here's this option 1 is this join order. Option 2 is this join order. Option 3 is this join order. And remember this, if there are 5 tables, how many different join orders are there? 5 times 4 times 3 times 2. Okay? So there are they'll all show up in there. Plus, they'll all show up for not just one time. So if there's 120 different options there, but it's 120 times each join method. 120 for nested loop, 120 for hash join, 120 maybe for sort merge join, but he's going to go through all those. And you'll see them all in the file there. And you'll see cost associated in there. Did he use an index? Not. Statistics that are involved. Any parameter settings that kind of caused him or influenced him to make his choice. They're all in this file. And again, here's what the file looks like. This is just part of the file. So here's like join order number 1. These are tables: channels table, times table, customers table, and sales table. 4-table join. All right. And so he's gonna label one of these. Table 0 is the channels table. It's up here on this line. It's kind of hard to read. Table 1, table 2, table 3. Those are the ones listed up here. And he comes up with different cost, different cardinalities. And this was the first one he did, so he says, oh, this is the best so far. And then he goes to a different order. You can see here he flipped the sales and the customer around on this one. And he comes up with something here. And if he comes up with something good on that, then if that's better than the first one, then this one becomes the best so far. If it's not, then he moves on to the third one, and so on and so on and so on. And then eventually, let's see, I don't have it in there, but he'll tell you which one he then eventually chose. Okay? And it looks just kind of like this, like you see here. This is just part of that file there. Easy to do. Do an alter session to turn it on. Run your query. Turn it off with an alter session or with a package. Check out the file. And now you can see what was the optimizer thinking. What did he consider? Oh, he considered this order, but he didn't choose it. Or he didn't even consider that order for some reason. Remember, the optimizer within reason may not try every possible combination, because if you're doing a 10-table join, that's just too many to think about. And he's also keeping statistics on each of these different options in there, and he knows that based on your predicate or your where clause that this one I just checked out is not the best. Then I'll go to the next one. He'll say, well, this one's basically the same as the last one, and so he'll ignore that one too. But that's what happens with this 10053. If this is something that you're not able to run yourself, you can certainly request that, say, a DBA or somebody like that run it for you, just so you can see the results there. Again, it just shows you the thinking behind it. It's not going to recommend anything to you, but it's going to tell you, hey, this is what the optimizer thought about in the order that he thought about, and why he chose this as what he thinks is the best execution plan. Okay, that's the 10053. That's all it tells us there, but it's kind of a good one. Again, if you notice from the previous slide, it's not something we do first. So if your query is running slow, we're not going to immediately do a 10053. We're going to do the usual things. Run it through explain plan, check out statistics, check out indexes, maybe run it through a 10046 trace event, which gives us different information about I/O and whether it was processed in memory or not, what execution plan it chose, and things like that. This will show you execution plans in here as well. Okay, so we usually kind of exhaust all the other things that we're looking at, and then we'll run through this and say, okay, why did I think this should have been the best plan, but he didn't come up with that. Let me just see if he even came up with, considered the plan that I thought should be best. All right, and you can see even with 5 questions there, that took up a lot of time there, so appreciate you sticking around as long as you did there. If you have any other questions, just email me at jmullins@themisinc.com later today and tomorrow, so give me a little bit of time. I'll send out some supporting information for this or recommendations on readings to some of you that you asked for that, so that'll be coming your way also. Here's some upcoming webinars. These all have to do with non-Oracle topics, but we've got IBM WebSphere, CICS, and one for DB2 coming up in the next couple of months. So take a look at those. Also go out to themisinc.com/webinars for you can get the slides for today from there, because we did have some sample code in here. You may want to take that, or if you forget one of the views that I told you, you may want to query for the storage indexes, just get a copy of these slides out there. And like I said, the recording, in addition to the slides, will be out there either late today or tomorrow, more likely tomorrow. Tomorrow takes a little bit of time to process. And then if you need any other information, just visit the website in general. You can send an email to John Cacavel. That's not me. Remember, I'm John Mullins. But John Cacavel can give you information about all the courses that are out there. And then go to webinars to get information about that. Okay, so hopefully on at least one of those 5 topics, we touched on something that'll help you a little bit if one of those questions was yours, or even if it wasn't your question, maybe it applies to your environment as well. So hopefully, because like I said, there's a lot of information, especially when we got in there on the Exadata and the storage indexes. There's still a lot more there to talk about. All right. Thank you for taking the time out of your day to attend today. I appreciate that. Appreciate you hanging around here to the end as well. Everybody have a good end of your day on Thursday here. You got the weekend coming up, so have a good weekend as well. And send me any questions that you might have, either related to these or unrelated as well, to jmullins@themisinc.com. All right, thanks for attending, and hope to see you soon in another webinar or class.